So we're going to go over the review problems in the revised final exam review problem sheet. So we start with a couple of problems on linear programming. We want to sketch a certain feasible region determined by some inequalities. So I'll do it very roughly by hand, and then I will do it in Maple, so we get a really good picture. So we have inequalities. The first is x1 plus x2 plus 2x2 less than or equal to 22. So this is a line which looks something like this. Let me just write, this is the equation of the line x1 plus 2x2 equals 22. So when x2 is 0, this is 22, 0. When x1 is 0, this is 0, 11. So, and of course, we always have the non-negativity condition, so we're only looking at points in the first quadrant. The second inequality is 5x1 plus 3x2 less than or equal to 40. So when x2 is 0, x1 is 8. And when x1 is 0, x2 is 40 over 3, which is a little bit more than 13. So we have a line that looks like this. This is the line 5x1 plus 3x2 equals 40. And this point on the x-axis is 8, 0. And this point on the y-axis is 0, 40 over 3. The third inequality is 5x1 plus x2 less than or equal to 30. That's a line which comes down like this. So this is a line 5x1 plus x2 equals 30. When x2 is 0, x1 is 6. And when x1 is 0, x2, this is way up here at 0, 30. And this, of course, is the point 0, 0. So this is the feasible region. And the corner point feasible solutions are what? Well, 3 we can read off very easily. This is a corner point. This is a corner point. 0, 11 is a corner point. What is this point? This is the point where these two lines cross. That means at this point, we're solving the system of equations 5x1 plus x2 equals 30. And this line is x1 plus 2x2 equals 40. And if you solve those two equations, that's just a little bit of high school algebra, you get sorry, this is x1 plus 2x2 equals 22. You get x1 is 2 and x2 is 10. So this point has coordinates write it in red. 210. What about this point? So this point is on the intersection of the line 5x1 plus 3x2 equals 40. And this line, 5x1 plus x2 equals 30. And if you solve two equations and two unknowns, you get x1 equals x2 equals 5. So this point has coordinates 5, 5. So there are 5 corner point feasible solutions: 0, 0, 6, 0, 0, 11, 210, and 5, 5. Now, if we take the objective function z equal to x1 plus x2, and we want to maximize this, first of all, this is for this equal to any value z, that means x2 is z minus x1. So this is just a line with slope -1 and y-intercept z. You want to make z as big as possible. So as you let z, it looks like that's going to occur right there. Graphically, that's how you would do it. If you also evaluate each of these critical point, each of these, so let me just write 0, 0, 6, 0, 0, 11, 210, and 5, 5. These are the critical point, corner point feasible solutions. If you let z equal x1 plus x2, for these points you get 0, 6, 11, 12, 10. That's the maximum. So the optimal value, the maximum value for your objective function z for this x1 plus x2 is 12. If you were to take z equal to 3x1 plus x2, and you evaluate at each of the corner point feasible solutions, you get 0, 18, 11, 6 plus 10 is 16, 15 plus 5 is 20. So for this objective function, it's at 5, 5 where you have the maximum value. And if z is x1 plus 3x2, this is 0, 6, 33. 2 plus 30 is 32. 5 plus 15 is 20. 0, 11. This would be the critical point. So solving this by hand, this is what you do. Now, if I want to use Maple to solve this, let me see if I can share my screen. So hopefully this is what you see. This is problem 1 of the linear programming problems. So I open the plots package so I can use the command inequal. So that gives me, here are my 3 inequalities. And I'm graphing this for x1 between 0 and 20 and x2 between 0 and 20. This is my feasible region. Exactly what, well, I mean, this is exact as opposed to the rough version I got by hand. If I want to find the coordinates of these 3 corner points, that's easy. But for these 2, I'm solving 2 equations and 2 unknowns. So before I could do it by hand here, I'm just having Maple solve these two equations and two unknowns, and I get 2, 10, and 5, 5, exactly the coordinates we had a moment ago. I open the optimization package, and I want to use the maximize function. So in the first case, my objective function is x1 plus x2, subject to these inequalities, including the non-negativity conditions. And I get 2, 10, and a maximum of 12, just what I did by hand. For the function 3x1 plus x2, I get the corner point 5, 5, and the maximum value 20. And for the objective function x1 plus 3x2, I get 0, 11, and the maximum value 33. Exactly what I did a moment ago. Okay. Let's see if I can stop my share. And now we're back to linear programming problem 2. So we have to formulate a linear programming model for the following problem. A store sells calculators and sweatshirts. So suppose let x1 be equal to the number of calculators sold. And x2, the number of sweatshirts sold. So the objective function, what we want to maximize is our profit. Z equal to what? Well, for every calculator, you make $5. So if you sell X1 calculators, you make $5x1. For every sweatshirt, you make $4. So, and if you sell X2 sweatshirts, you make $4x2. So this is the objective function. And what are our constraints? So to sell a calculator takes 2 minutes of a sales clerk's time and 2 minutes of a cashier's time. So for every calculator, it takes 2x1 minutes from a sales clerk and 2x1 minutes from a cashier. So this is the clerk. This is cashier time. If you sell a sweatshirt, it takes 3 minutes of a sales clerk's time. So if you sell X2 sweatshirts, it takes 3 minutes of a sales clerk's time, so plus 3x2, and it takes only 1 minute of the cashier's time, 1 times x2. Now the store is open a maximum of 2 hours a day. Since this time is measured in minutes, 2 hours is 120 minutes. But there are 2 sales clerks and 1 cashier. So the total number of, there are 2 sales clerks. The number of minutes of clerk time is 2 times 2 hours or 4 hours, which is 240 minutes. There's only 1 cashier. So in 2 hours, that person has 120 minutes. So we have these 2 constraints together with the non-negativity conditions. So our problem is maximize this objective function subject to these constraints. And we have to do this in 2 ways. So one is just to have Maple do it. So again, let me switch to Maple and see what the solution looks like. Share screen, Math 348, share. Okay, so well, it's just 1 line. So this we've already opened the optimization package, right? That's already open. So we want to maximize the function 5x1 Oh, I'm sorry. Yeah, 5x1 plus 4x2. That's a mistake. I should have put a 4 there. Subject to the constraints, 2x1 plus 3x2 less than or equal to 240, 2x1 plus x2 less than or equal to 120. And this says we should try to maximize our profit. We should try to sell 30 calculators, 60 sweatshirts, and our profit will be $390. So Maple does it all in a moment, instantaneous. It's very easy. All right, but then we also want to do it using the Simplex method in tabular form. So let me stop the screen share. And let's introduce the Simplex method. So we have to put in our slack variables. So this first inequality becomes an equality if we make this 2x1 plus 3x2 plus the slack variable x3 equals 240. 2x1 plus x2, and we add the slack variable x4 equals 120. And now we have x1 greater than or equal to 0, x2 greater than or equal to 0, x3 greater than or equal to 0, x4 greater than or equal to 0. And the function we want to maximize, let me just write it like this, z minus 5x1 minus 4x2 equals 0. So this is the linear programming problem when I've introduced slack variables and converted every inequality to an equality. So let me now set this up as a Simplex Tableau. So I have columns for the variables z, x1, x2, x3, x4. And this equation, if you write down the coefficients, you get 1 minus 5 minus 4, 0, 0, 0. For this equation, coefficient of z is 0, 2, 1, sorry, 0, 2, 3, 1, 0 equals 240. For this equation, 0, 2, 1, 0, 1, 120. And the basic variables in this are x3 and x4. Now we look to see if there's a negative number on this line. In fact, there are 2, and we choose the largest. The largest is minus 5. So in this column, we look at the ratio, 240 over 2, which is 120, 120 over 2, which is 60, and we choose the smaller of those two numbers, which is 120. So in this column and this row, this is the pivot number 2. So I want to make this a 1. So I can multiply this whole row by a half. I get 0, 1, a half, 0, a half, 60. I want to get a 0 here. I could just take this line minus this line. 0, 0, 2, 1, minus 1, 120. And I want a 0 here. So I add 5 times this row to this row. I get 1, 0, minus 4 plus 5 halves is minus 3 halves. 0, minus 5 halves, minus 5 times this. Oops, sorry, this is plus 5 halves. And 5 times this is 300 plus 0 is 300. And now my basic variables are x3 and x2. I'll look and see if there are any negative numbers on this row. There's only 1. So this is certainly the largest in absolute value. So I look at the ratio of 120 over 2, which is 60, 60 over a half, which is 120. The smaller of these two is 120. So in this column, in this row, that's the pivot number. So I want to make that a 1, which I can get by multiplying this row by a half. I get 0, 0, 1, a half minus a half, 60. I want to get a 0 here, so I can take this minus 4 times this row plus this row. So I get 0, 1, sorry, not minus 4, minus a fourth. 0, minus a fourth. A fourth plus a half is 3/4. Minus a fourth times this is minus 30 plus 60 is 30. I want to get a 0 here, so I can add 3 halves times this row to the top row. I get 1, 0, 0. 3 halves is 3/4. 3 halves is minus 3/4 plus 5 halves. So 5 halves minus 3/4 is 7/4. Three halves oops. Let's see. Something here I didn't do correctly. Let me just go back. This is to this tableau. So I multiply this row by a half. I get 0, 0, 1, a half minus a half, 60. Then I want to get a 0 here, so I can take this row. I can take this row minus a half this row. So it's minus a half plus 0. So 0 plus 0 is 0. 0 plus 1 is 1. Minus a half plus a half is 0. Minus a fourth plus 0 is minus a fourth. A fourth minus a half times minus a half is a fourth. A fourth plus a half is 3/4. And minus a half times 60 is minus 30, and 60 minus 30 is 30. So this is okay. Now I want to get a 0 here. So I take 3/2 this row plus this row. So 0 plus 1 is 1, 0 plus 0 is 0. 3/2 plus minus 3/2 is 0. 3/2, this is 3/4 plus 0 is 3/4. 3/2 is minus 3/4 plus 10/4 is 7/4. 3/2 of 60 is 90, plus 300 is 390. And now my basic variables are x1, oops, this was x1, and x2, and there's no negative number here. So I've done my arithmetic, and I set x3 and x4 equal to 0. This says x1 is equal to 30, x2 is equal to 60, and my maximum profit is $390. So that is the solution to the linear programming problem. So I think in these two problems, I've covered all the various topics we discussed in linear programming.